Dear students, we have discussed Newton's divided difference interpolation and Lagrange interpolation, where we find the value of y or the function for a given x and the set of data points x was unequally spaced. Then we will switch over our attention to find the value of y for a given x where the set of data x are equispaced. Under that head, we will come across two formulas, that is Newton's forward difference interpolation formula and Newton's backward interpolation formula. But before going to discuss about the Newton's forward difference interpolation formula and Newton's backward difference interpolation formula, we should be acquainted with the different operators what we use in numerical analysis. The different operators are forward difference operator, backward difference operator, shift operator and central difference operator. Okay. So mainly we will discuss these two forward and backward difference operator which will be used in Newton's forward difference interpolation and Newton's backward difference interpolations. So let us start. What is forward difference operator? Okay, say we are having the set of data as x and y. Okay, and this is x0, y0, x1, y1, x2, y2 and x3, y3. Okay, just we assume these four datas. Okay, then how we define the forward difference operator? Actually, this forward difference operator is denoted as this. This is the notation for forward difference operator, the triangle sign. Okay, so here we write delta. This is the forward difference operator. So that will be defined as y1 minus y0 and it will be denoted as delta y0. Okay, that means the new data minus old data is denoted as delta y0. Similarly, y2 minus y1 is delta y1. Here y3 minus y2 will be denoted as delta y2. Right. So this is the table for delta y0, delta y1 and delta y2. So this table is called as first order forward difference. Okay. Similarly, we can go for the second order. For second order difference, the notation is delta square. This is second order forward difference. Right. It is the second order forward difference is defined as delta y1 minus delta y0. Okay, so this is the new data, this is the old data. So that will be denoted as delta of delta y0 and shortly it will be written as delta square y0. Okay. Similarly, here delta y2 minus delta y1, it will be denoted as delta of delta y1 and its notation is delta square y1. Right. Similarly, again if we move further, that is for delta square. After that delta square, that is delta q. What will be delta q? That is delta square y1 minus delta square y0. That is delta q y0. Okay. So by that order, we will proceed till to get only one data. That is the forward difference table. Now let us have a definition for this. That means forward difference operator. It is defined as delta yi, that equal to yi plus 1 minus yi. You see, here what we have used y1 minus y0 means next data minus the old data. Here if yi is the data, yi, this is the next data, yi plus 1. That means the new data minus old data, we are finding delta yi. Okay. When we take the notation, we use the notation for this. Okay. Now from that, we will find delta square yi. What is that? That is delta of delta yi. That is delta of delta yi is this. That is yi plus 1 minus yi. that is by the linear operator delta of this can be written as delta yi plus 1 minus delta yi. Again, if we apply the forward difference definition here and here, we get that is delta of yi plus 1, that gives yi plus 2 minus yi plus 1 minus delta yi is yi plus 1 minus yi. If we simplify it, that gives yi plus 2, this is minus 2yi plus 1 plus yi. Okay, so this is the result for delta square yi. Now we found delta yi is equal to yi plus 1 minus yi. Then we find delta square yi, that equal to yi plus 2 minus 2yi plus 1 plus yi. Then let us find out delta qyi. So delta qyi, that equal to delta of delta square yi. Already we have found out delta square yi, that is delta of yi plus 2 minus 2yi plus 1 plus yi. Then apply the linearity property, that means delta of this minus delta of this plus delta of this. So that gives delta yi plus 2 minus 2 delta yi plus 1 plus delta yi. Again you apply the definition, delta yi means yi plus 1 minus yi. If you apply this here, that gives yi plus 3 minus yi plus 2 minus 2, this is delta yi plus 1, that will write yi plus 2 minus yi plus 1 plus, this is delta yi, that is yi plus 1 minus yi. Just we are using definition of first order difference for every data. Okay, so that gives yi plus 3, this is minus I plus 2, this is minus 2i plus 2, that gives minus 3y I plus 2, then this is minus minus plus 2y I plus 1 and plus I plus 1, that is 3y I plus 1 minus yi. Okay, now you just look at 1, 2 and result of 3. Okay, and by observing this, now you can write the nth order, delta n yi. Okay, how we can write this? You see, in first order its coefficient is 1 and 1, but sign is changing alternately plus minus. Second order, this is plus minus plus. Third order, plus minus, means always the signs are changing alternatively. Next you come to the index. When we have started the order as 1, it is 1 and I, this is I plus 1 I. This is order 2, so I plus 2, then I plus 1 I. When order is 3, I plus 3, then 1 decreases, I plus 2, then again 1 decreases, I plus 1, then I. That means if this is the order and this is the index, so this first index will start from this plus this. So delta n yi, it will be started as a delta, this is I plus 3, we will start I plus n. Okay, then alternately sign is changing, after this plus we will write minus. Okay, then what will happen? So then we will write y, this is I plus n minus 1, but what about this coefficient? I will come across, then this is minus, then this is plus, this will be y I plus n minus 2. Okay, like this we will proceed. Okay, I will come to the last term, but now you think what is the coefficients? Again you come to the first, the coefficient is 1, here 1, forget about the sign. Here coefficient is 1, 2, 1, here coefficient 1, 3, 3, 1, and this is nothing but the binomial coefficients. Means if here it is n, we can write this coefficient as n0, this coefficient as n1, this coefficient as n2, like that. If we proceed, so the last term will be n y I. But what about this sign? This sign will depend as per the n, that is minus 1 to the power n. So this is the general formula for the forward difference table. Okay, so this is all about the theoretical part of the forward difference table. Now we will work out a numericals on it. Now we will discuss one numericals relating to forward difference. So this is the set of data x and y. Okay, and you know that we apply the Newton's forward difference interpolation for equispaced data. Okay, so here we consider x as say 2, 4, 6, 8, 10. Okay, so this is the set of data, and for this y, say this is 10, 12, 18, 13, 20, right? Then we have to find out the first forward difference operator, that is 12 minus 10, that is 2, 18 minus 12, that is 6, 13 minus 18, that is minus 5, 20 minus 13, that is 7. Clear? Then we will write second order. 6 minus 2, this is 6 minus 2, that is 4. This is minus 5 minus 6, that is minus 11. This is 7 minus of minus 5, 12. This is our second order. Then go to the third order, that is minus 11 minus 4, that is minus 15, that is 12 minus of minus 11, that is 23. Then next order, delta 4, 23 minus of minus 15, that is 38. So in this way we form the forward difference table. Find delta square y2. So that equal to, so this is what? So delta square y2 is equal to 2 0 y2 plus 2 4 plus minus 2 1 y4 then 3 plus 2 2 y2. Okay, because this is 2 means this is the end. So that equal to 2 0 is 1, that is y4, minus 2 1 is 2, that is y3, plus 2 2 is 1, that is y2. Then you come to the table. This is y0, y1, y2, y3, y4. Okay, so that gives y4, that is 20, minus 2y3, y0, y1, y2, y3, that is 2 into 13 plus y2, this is 18. Okay, the result you will get, that is 20 minus 26 plus 18, that is minus 6 plus 18, that is 12. Okay, this is the result, because this is delta square y0, delta square y1, delta square y2. Okay, so this is delta square y2 and we have found delta square y2. So this is the result from the table, this is the result directly from the formula or the equations. Okay, is it clear? So in the next video we will discuss the backward difference. Thank you.